Welcome to the series Photographic Chemistry, presented by the Foundation of the American Institute for Conservation of Historic and Artistic Works. This program was made possible by grants from the National Endowment for the Humanities and the Andrew W. Mellon Foundation. Each program in this series is presented as a short video. Depending on your video viewer, you should be able to pause, return to a previous section, or skip ahead to a later section by using a scroll bar or on-screen icons. You will find an outline of the course and short quizzes to test your understanding on the course webpage.
There are other point defects which also occur in silver halide grains that have an impact on the sensitivity of a silver halide film or paper-based emulsion. And these are impurity defects. These are areas where a silver or a halide should be, but instead another ion has taken its place. There are two main types of impurity defects that can be seen in silver halide chemistry. These are monovalent and divalent impurities. Remember back on the emulsion equation that I showed in the very first slide that I said back in the day they were using cadmium and lithium salts. When they did this, they didn't realize at the time, when there was no expectation of the concepts of latent image theory, they didn't expect that using these salts, they would actually produce a silver halide emulsion that was less sensitive than if these impurities were not present. If you think about what I'm saying, if we go back to the idea of silver mobility being extremely important, but what if I place another equally charged or even more positively charged ion right in the middle of the works, if you will? Another positive charge of a different type of ion is going to impede this silver flow. And so if silver is not able to freely move by these Frankel defects within the grain, you're going to slow down the ability for latent images to be formed, and it'll be as if the film was of a slower speed. This occurred with cadmium being present, so a divalent impurity, a point defect where cadmium actually takes the place of where silver should be. Lead has this effect. Copper, sodium, the lithium they would use would have an impact on film speed. Now that was to the negative impact. I can actually have a positive impact and make the film extremely sensitive by placing an impurity defect which is negatively charged. Iodide has this property, and a more important one, sulfide has this property. A sulfide is a big 2- charged anion. If you think about silver mobility, a little bit later in latent image theory, we're going to talk about that silvers need to congregate, and they congregate faster if they are pulled to a certain location within the grain at about the same time. This is what the sulfide ion does. There is a classic story in the history of Kodak where back in the middle 20th century, they were sending out Brownie cameras, and these Brownie cameras were coming back for development, and the film was coming up fully exposed. All the film was black at a full silver density. And it was hard to believe that everybody's cameras were being overexposed at the same time. And so they're starting to get the complaints. This effect, this problem in the product almost sunk Kodak back in, I believe it was in the middle 1950s. And they did some research. They're trying to find out what was going on. Well, what they found out was they changed their gelatin source. And their gelatin was coming from the Midwest, and I believe it was somewhere around Iowa, where the feed for the cattle, which they used to make the gelatin, was very rich in sulfide. So that when they were making the gelatin, there was a lot of sulfide present. They didn't anticipate the sulfide being there. And so when they made the emulsions, they were making a much more sensitive emulsion than was anticipated without the sulfide being present. As a result, with it, what was considered to be a normal exposure was actually an overexposure by several stops in the film. And again, if they hadn't caught this problem as fast as they did and knew a little bit about the effects that impurity defects could have in silver halide emulsions, we might not have seen Kodak beyond the middle 20th century. So positive impurities, as shown on the slide, has a way of modulating the sensitivity of a silver halide emulsion by slowing it down. It does this by displacing silver, and it lowers ion movement or conductivity. On the reverse, negative impurities are often added for two purposes. One, to control habit growth. We've already talked about this, where if the halide is in excess, we tend to get non-cubic crystal structures. But in the context of this discussion, negative impurities also have a way of creating what are known as these ion traps, which affect sensitivity and increases the sensitivity. Ion trapping is what we're going to talk about in latent image theory, and it becomes a very important concept again. So silver mobility, silver conductivity is influenced by all these point defects that might be present during the emulsification process.
You have completed this unit. Depending on your video viewer, you should be able to scroll back to any point in the video as desired. The short quiz found in the course materials on the website may help you confirm your understanding of the concepts introduced here. Many thanks to the instructor, production editor, coordinator, and the Collaborative Workshops in Photograph Conservation Committee for their work to make this program possible.